So we want to arrange all of the fractions that we have here in order of size, and they say to begin with the largest. So when they say to begin with the largest, this is basically telling us we are going to arrange these fractions in what we call descending order. So for us to arrange the fractions, we need to be able to identify which of the fractions is the largest, and then which one would come next until we get to the smallest fraction. And the only way that we can come up with a comparison for the fractions, we need to bring these fractions, these three, need to be brought to a common denominator so that we can create each of these fractions equivalent fraction out of the common denominator. That way it makes it easier for us to do our comparison. So for us to get a common denominator, first of all, we need to look at the denominators that we have here, and you'll notice that we have 8, 4, and 3. So it's not as easy as just take one of the denominators that they already gave us. We have to find the LCM of the three denominators. So let's say we have to find the LCM here, in this case of 8, 4, and 3. So we want the LCM of 8, 4, and 3. We'll first start off with writing our three denominators. Now you could also list out the multiples of 8, 4, and 3 until you get to a common multiple, right? And you can also get your denominator like that, but this way it might be a little faster. So we can just consider a number that could divide at least one of these numbers, and in this case I can see that 8 and 4 both have a common factor of 2, so I'll start with that. Whenever we're doing LCM as well, we want to always remember to keep the factor that we're dividing by as low as possible, doesn't have multiples within it. So you prefer to work with something like a prime factor. So considering 2 into 8 would give me 4, 2 into 4 would give me 2, and 2 cannot go into 3, so I just leave the 3 as it is. Again, 2 could go into 4 and 2, so I'm going to say 2 into 4, 2, 2 into 2, 1, and still 2 cannot go into 3, so I'll leave the 3 as it is. Repeat the process one more time. 2 into 2, 1, 2 can't go into 1, so we write back the 1, and 2 cannot divide 3 exactly, so we write back the 3. Remember, the objective of doing this process to get your LCM is that you want to make sure when you're finished you have a row of 1s. So right now we already have 2 of these numbers being 1s. We want to convert this last one into a 1, so it's obvious we're going to divide by 3. So 1 cannot be divided by 3, so we just write those back, and 3 into 3 gives us 1. So like I said, the objective when finding the LCM is to make sure that we have a row of 1s, and that was achieved. Now to get our LCM, we're going to take the product of all the numbers that we just divided by. So we just divided by 2 3 times, and then by a 3. So to get the LCM, we're going to work out this product. Okay, so let's work out the product, and the product would give us 2 by 2, which is 4, and 4 by 2, which is 8, and then finally 8 by 3, which would give us 24. So our LCM for the 3 denominators that we have here, the LCM is 24. So we are going to write these 3 fractions as fractions out of 24. Okay, so let's start with converting the 3 fractions into fractions out of 24. To do this, we're going to ask ourselves how many times 8 could go into 24. So we'll start with the first fraction. 8 into 24 is 3, and we're going to take that multiple, and we're going to take that factor, and multiply 5 by 3. So whenever we want to convert a fraction to an equivalent fraction, we have to remember what we multiply the denominator by, the numerator is also going to be multiplied by that, and vice versa. So because we're considering how many times 8 could go into 24, essentially we're saying that to get 24 we had to multiply 8 by 3. So we multiply now 5 by 3 to get a numerator, and 5 by 3 is 15. So if I had to say, well, what is 5/8 as an equivalent fraction out of 24? I would say that 5/8 is 15 out of 24, right? 15 over 24. So I'm going to repeat the process, but I'm going to do that for my fractions of 1/4 and 2/3. So now I'm going to say, well, how many times can 4 go into 24? So 4 into 24 is 6. And 6 times my numerator of 1 will give me 6. So 1/4 as an equivalent fraction out of 24 is 6 over 24. And then finally we're going to do our last fraction, which is 2/3. We're going to ask ourselves the same question. How many times can 3 go into 24? So 3 into 24 will give me 8. And I'm going to take the 8 and multiply it by my numerator of 2. So 2 times 8 is going to give me 16. Alright, so it's important here to be able to understand how to identify multiples versus factors. And it's important to remember your multiples because you have to do that multiplication process in doing the conversion. So now that I have all 3 fractions as equivalent fractions out of 24, it's going to be easier for me to make a comparison among my 3 fractions so that I'll be able to figure out which one is the largest and which is the smallest. So for us to identify the fraction that is the largest, we're going to look for the fraction that has the largest numerator. So of all the 3 numerators, I'm going to compare to see which numerator is largest. And the numerators we have to compare would be these that we just created. The equivalent fractions is what we're using to do our comparison, to be able to identify our largest fraction. So if I look at the 3 numbers, if I look at 15 and I compare it to 6, 15 is larger than 6. But if I look carefully, I will notice that 15 is not larger than 16. So my fraction that is the largest would be 16 over 24, which means that 2/3 is my largest fraction. So when I'm writing the fractions now in order from largest to smallest, I'm going to put 2/3 first in the lineup. So I'm going to write 2/3 first. After 2/3 would be my second largest fraction. So we were comparing earlier and we saw that we had a numerator of 15 and we have a numerator of 6. And we know for a fact that 15 is definitely larger than 6. So our next fraction to be written in the lineup would be the fraction that is equivalent to 15 over 24. So this fraction being 5/8, the next fraction in our lineup, we are going to write 5/8. And we're only comparing 3 fractions, so we just need to know that the last fraction here is going to be 6 over 24, which is equivalent to 1/4. So our 3 fractions are now in order according to size, where we start with the largest and we go down to the smallest. So just in case you want to remind yourself what you call that order, if you're going from largest to smallest, remind yourself it is called descending order, right? Descending order. So we just put these fractions in order according to descending order.